Welcome to the fourth lecture video in our Class 24 time series of lecture videos. In this lecture video, we're going to talk about retrosynthesis, now incorporating all the tools in our toolbox that we know about. It's another type of question I have available to try to test what you know. Let's say we wanted to get this molecule. Geez, what is this molecule? 2,6-dimethyl 2,6-heptane diol. 1, 2, 3, 4, 5, 6. Yeah, that's what it is. What if we were told you have to make this from cyclopentanol and methyl bromide and any other inorganic reagents and starting materials that you might need? Well, you'd have to use retrosynthesis, right? Unless you were brilliant and you could just think of it forward and you were AI and, you don't have a job. Because yeah, some computer has that job instead. Well, anyways, here we go. We could make our diol from what? A Grignard of two equivalents of methyl magnesium bromide on this dicarbonyl compound, this dicarbonyl diketone, followed by aqueous acidic workup. Of course, how could we make this? Well, ozonolysis of this cyclopentene, 1,2-dimethyl cyclopentene. How could we make that cyclopentene? Well, geez, E1 dehydration of this 1,2-dimethyl cyclopentanol. I'm not specifying any stereocenters. How do we make that molecule? Well, we simply add methyl lithium followed by aqueous acidic workup to this methyl cyclopentanone. How do we get that? Well, we oxidize this methyl cyclopentanol. How did we get that? Well, maybe a hydroboration followed by oxidation of this methyl cyclopentene. How did we get that? Yes, E1 dehydration of methyl cyclopentanol. How did we get that? Well, maybe methyl lithium Grignard reaction with this cyclopentanone. How did we get cyclopentanone? Oxidation of cyclopentanol with PCC. Hey, we've worked back to what we need to work back, cyclopentanol, right? And how, of course, did we get our methyl lithium? Well, or our methyl magnesium bromide? Well, you just work back to methyl bromide and magnesium or methyl bromide and lithium. Quite easily done. And of course, forward direction is the only direction that you get points if you were taking the tests and it were like actually free response. But yeah, forward direction is probably the only direction you get points for in your multiple choice, but who knows? Maybe I could write multiple choice questions with retrosynthetic analysis. Anyways, here we go. We take our cyclopentanol, oxidize it with PCC, add methyl lithium, then aqueous acidic workup. Oh, look, we're at methyl cyclopentanol. Treat it with H2SO4, E1 dehydration, which we hydroborate, followed by oxidation. We get the boron on the less substituted carbon. That's where the oxygen goes. Primarily, that's our major product. Then we do PCC. Methyl lithium, we really don't care about that stereocenter, right? Because we're just going to get rid of it. Aqueous acidic workup, and then H2SO4 and heat to give us the most stable tetraalkyl substituted alkene, which we ozonize to get our 2,6 pentadione, or heptadione. Excuse me, it's a heptane. And then we treat that with two equivalents of methyl magnesium bromide followed by aqueous acidic workup to get the diol that we wanted. All right, well, there's that. I think our next lecture video is going to be a long one. Best of luck, of course, and don't forget to make the Grignards, right? Methyl bromide plus magnesium in some ether solvent, I'm sure, right? Like tetrahydrofuran or diethyl ether, or you could just throw in lithium chunks to methyl bromide in THF or diethyl ether, whatever, and you could get your methyl magnesium bromide or methyl lithium. All right, we'll see you for the next and last video, and then it'll all be PowerPoint for the rest of the semester. Yay.